Physical and chemical properties. So let's talk physical properties first. Physical properties. So we got physical and chemical properties. All right, so physical property. All right, so there's two types. You have extensive and you have intensive. All right? And extensive depends on the amount of substance present. Intensive does not, is independent of the amount of substance present. So what are some of these properties? Well, extensive would be like mass, volume, temperature, some intensive ones would be like melting point, boiling point, color, density. All right. These are all physical properties, and some depend on the amount, right? And some depend on not the amount. Okay. And so, but they're all, describing, right, our substance. They're describing what we're talking about. Then there are chemical properties. In chemical properties, these are more behavior. Think behavior. So appearance, or observables, maybe, right? Okay, but chemical properties are behavior, such as corrosiveness. Right? Does it promote oxidation? Does it promote electron transfer? Flammability. Acidity. Toxicity. Right? Etc. So these are like, okay, we don't store our phone in the sink or your laptop computer in the sink, right? Or in the bathtub, because if it gets wet, not good, right? But if you might store, right, because that's not good. But you can put your computer on a table, and that should be fine, right? We know if you put paper on the table, nothing's going to happen. We know you put paper in flames, it's going to burn, right? We understand, like, these are physical properties or chemical properties, and it's their, what they're going to do, what they're going to react with. All right, so what we talk about then is physical and chemical change. All right, so a chemical change changes the identity of the substance. Which would be the formula, right? The chemical formula. A physical change does not. Change the identity. All right. So a couple examples. Right? If I have ice and that goes to water, right? That would be a physical change. In fact, we're going to eventually write it as H2O solid going to H2O liquid, right? It's the same chemical formula, same material or substance. Okay. What about hydrogen and oxygen going to water? Well, that would be chemical. Right? That was the example we did before, where you have two elements making a compound. New formula, new substance. What about sulfur burning to produce sulfur dioxide? Well, that would also be chemical. Just so we know, anytime you see burning, this is a reaction, usually with O2, oxygen gas. So burning is usually a reaction with oxygen. Then we have salt dissolving in water. So if salt's dissolving in water, right, I'm just mixing, that's going to be physical. It's going to be NaCl plus H2O, and they stay together. They're not changing. And what about when a flashlight battery runs down? Well, that's going to be a chemical change, right? So those are some examples of physical changes and chemical changes.